Rational functions. So when we start looking at rational functions, where we're looking at variables in our denominators, we're going to start getting back into our quadratics and our binomials again. There are certain values that we'll need to exclude, and if we think back to our inverse variations that we were working with, we noticed that there were certain values we really couldn't work with. When we had x times y equals k, we couldn't have x or y be equal to 0, because multiplying by 0 cannot give us a real number. It will automatically give us 0. So let's take a look at what those excluded values look like in a rational function. So the function y equals 10 over x is an example of a rational function. Because division by 0 is undefined, any value of a variable that results in the denominator of 0 must be excluded from the domain of that variable. These are called excluded values of the rational function. To find excluded values, set the denominator equal to 0 and solve. So pretty straightforward. If I don't want the denominator to be equal to 0, I'm going to imagine what would the values of that variable be that would make the denominator equal to 0, solve for it, and then make sure I exclude those values from my domain of that variable. So state the excluded value for each function. I have y equals x minus 3 over x plus 1. I'm going to set just the denominator. Again, the numerator can be whatever it wants. It's the denominator that's the problem. So x plus 1 equals 0. Solve for x. I get x equals negative 1. Pretty straightforward. So x cannot be negative 1 here. It's going to be excluded from my values of x. And my second one, y equals x over 7x minus 35. I'm going to set 7x minus 35 equal to 0. See what happens here. If I add 35 to both sides, divide by 7, I get x equals 5. So x equals 5 is the excluded value for this rational function.